Welcome back, guys. So this is sort of part 2 of a video that I put up several weeks ago where I'm showing you guys the equipment that I use when I'm making stuff. Last time was all about soldering and working with electronics, and if you missed that one, then I'll link to it below. This time is going to be all about 3D printing, and I've got a lot to cover, so let's get started. So before I get into anything, I want to announce the winners from the Quad Hands giveaway that we did last time. So congrats to Jonathan from Texas and Daniel from Montana. I hope you guys enjoy your Quad Hands, and a big thanks to Quad Hands once again for making that happen. I'll be doing more giveaways and even some competitions soon, so keep an eye out for that. So I get asked pretty frequently which 3D printers I use and what do I like and dislike about them. So if you've been curious about that, or maybe you're just getting into 3D printing and trying to figure out what to look for in a 3D printer, then this video is for you. And I'll be explaining some basic concepts as I go along. So if you're already a 3D printing veteran, then hopefully that doesn't bug you too much. Right now I've got 5 different 3D printers in my workroom. And I don't know your situation, I don't know what kinds of things you want to print, what kind of features are important to you. So rather than telling you which 3D printer to run out and buy, instead of that, what I'm going to do is I'm going to go over each one of my printers and tell you a few things about each one of them that I've come to really like and that I don't like. I'm hoping that this will give you guys some things that you can keep in mind and consider when you're comparing printers and trying to decide which one to buy. And I can already tell you this is going to be a longer video than normal, so I'm going to link below to some different timestamps in this video so that you can skip between the different printers if you want to. So first up is the Lulzbot Mini. I've had this printer for about 2 years at this point, and I still use it nearly every day. It's one of the most dependable printers that I have. Now, before I get too far, I should mention, just a couple of days ago they announced that they'll be coming out with a new version of the Lulzbot Mini. So not everything that I'll talk about on this printer will necessarily apply to the new one as well, but I think it's still worth going over because I could see a lot of people looking to buy used ones of these soon, and a lot of the concepts and features that I'll talk about aren't necessarily specific to this printer anyway. The first thing that I really like about it, and that kind of drew me to it in the first place, is the build plate. A really common issue that people run into with 3D printing is just getting your model to stick to the plate and stay there during the rest of the print. There are a lot of things that factor into this, but a lot of the big ones come back to the build plate. Specifically what it's made out of, whether or not it's heated, and how level it is. So the plate on this one is glass, and it's coated in a sheet of PEI. And PEI is just a really tough kind of plastic that when it's hot, other kinds of plastics like to stick to it. And when it cools down, those same plastics will oftentimes just pop right off of it. So it really makes for an ideal printing surface. And then it's heated with this pad attached to the bottom side of the glass plate. So right there, that makes it a lot easier to get things to stick to it, and it makes it so you can print in a much wider range of materials. Some things like ABS, you're gonna have a really hard time printing with if you don't have a heated build plate. And then finally, it has automatic bed leveling, which is a big one. So when I say bed leveling, what I mean is making sure that the distance between the nozzle and the plate is consistent across the entire surface. If there's any variation in that at all, you can wind up with issues getting your print to stick to the bed, or you can have corners on the bottom of your print lift up, or you can just wind up with a really uneven surface finish on the bottom of it. A lot of cheaper printers, and even some more expensive ones, leave it up to you to make sure that your bed is level, usually through a series of springs and screws on the bottom of the build plate that you have to adjust and measure with like a sheet of paper or something. It can just be a huge pain to dial in, which can be frustrating considering how important it is. So the way that automatic bed leveling works on most printers is there will be some kind of mechanism in the printer to measure the variation in the distance between the nozzle and the plate across several points on the surface of the build plate. So once it has those measurements, while it's printing, it can interpolate between those measurements that it took and raise and lower the nozzle by a tiny bit to compensate for any of that variation. Most of the time it works really well. So the next thing that I really like about this printer is just the construction of it. It's got this sturdy steel frame that when you pick it up and move it around, you don't feel like you're gonna knock anything out of alignment. In fact, it's even got this handle up under here, which kind of tells me that they expect you to pick it up, take it to, maker fairs and hackathons and things like that. It's just really sturdy. I love that about it. And then the third thing that I really like about this and some other printers is that it uses 3D printed parts on the printer itself where it makes sense, and those parts are actually open source, so you can download them and print them out if you need to. I remember when I first got this printer, my wife was asking me if they were just being cheap and trying to save money by using printed parts, but that's really not the case at all. What's great is if you have a part that's starting to wear out, you can just download the model, print it out, and replace it. Additionally, as they come out with refinements and updates to all the parts, you get to download those, print them out for just pennies, and you've upgraded your printer. And that kind of speaks to the company that makes the printer more than it does the printer itself. Aleph Objects is renowned for adopting open source and being transparent with their whole design process. So at any given time, you can go on their development website and see what they're working on before it's even out, which is pretty cool. Okay, so now a few things that I'm not a huge fan of on this printer. First of all, the auto bed leveling. And let me explain, because I know I just said that that was something that I liked about it. So the way that it works on this printer is it has these metal discs at every corner. And when it starts a print, the nozzle positions itself over each one and lowers itself down slowly and then records the exact Z value of where it touches that disc. The problem with that is it has to have a nice clean direct contact between the nozzle and the washer, or else it doesn't know that it's touched it. So if there's a bit of plastic between it, maybe from your last print, or even just a piece of dust, sometimes that can make it so the nozzle mashes into that disc and it doesn't know it. If it does make contact when it's pushed it down, then it winds up recording the wrong height. And I can't tell you how many times I've started to print and the nozzle just kind of mashes itself into the build plate when it starts, and you have to stop the print and start it all over again. It tries to compensate for this by having this wiping pad on the back of the plate, but that doesn't always clean it off all the way. So again, like I say, when it works really well. When it doesn't, it's really frustrating, and it happens a lot more than it should, I think. The new version of the Mini looks like it's going to use that same bed leveling process, so that issue is probably going to be there for that as well. The other things that I'm really not a huge fan of on this version of the Mini are actually all going to be fixed in the next version, but I'll still mention them just in case you're looking to pick up a used one or something like that. So first of all, the stock tool head. So for some types of material like PLA, which happens to be one of the most popular out there, it's important to cool off the plastic right when it comes out of the nozzle. If you don't, then you can end up with some really messy prints because the plastic will stay warm and droop. Problem with the stock tool head is it only cools the part on one side of the nozzle. So you end up with one side of the print that looks really good and one side of it that looks kind of messy. As you can see, I've already upgraded mine to the new tool head, which cools it from 360 degrees. So there may be some designs that you can print out to modify this fan shroud to make it cool it from all around, but in my opinion, you shouldn't really have to do that yourself. That should be a priority from the beginning with the design of the tool head. And then the last thing that I'm really not a fan of on this version of it is it's pretty loud. 3D printers can range anywhere from near silent all the way up to just really annoying to be in the same room with. I would say that this is probably closer to that end of the spectrum. But on the new version that's coming out, it's going to be near silent, so that's going to be a huge upgrade right there. So if you were to take the Lulzbot Mini and just kind of stretch it out, you'd get the Taz. And even though it's a lot bigger and it looks pretty different, it actually shares a lot of the same design and features of the Lulzbot Mini, for better or for worse. And that's actually a pretty common thing that you'll find among printer manufacturers, is they'll have a couple of different sizes of roughly the same design. So if you don't have a lot of room and you're not worried about printing anything really big, you can go for a smaller, cheaper option. But if you need to be able to print really big things or lots of really small things at the same time, you can go for something like this. So it has the exact same build plate, it's just a lot bigger, has the same method of auto bed leveling, the same nice, incredibly rigid steel construction that the Mini had, same basic design as far as the X and Y axis, and it also uses 3D printed parts throughout the printer that you can download and print out if you need to. It does have a couple of things that the Mini doesn't have. For one, it has this screen and control wheel right here. It lets you tune some things while it's printing, like print speed, flow rate, and some other things like that. And it also has an SD card slot on the side. So that'll let you load your prints onto the SD card and print them directly from the printer without needing to have it tethered to a computer while it prints. Another thing that it has that the Lulzbot Mini doesn't have is support for dual extruder tool heads. So you can get tool heads that have 2 hot-ends on them and 2 extruders, which lets you print in 2 different materials at the same time. That can be a lot of fun, but also really useful because it'll let you use water-soluble support, so you can print things that you just wouldn't be able to otherwise. So like I said, it has the exact same bed leveling process as the Lulzbot Mini, with all the same drawbacks that it had. Since the glass sheet is so big, you can wind up with a little bit of warping in it if everything isn't perfectly aligned in the y-axis. Specifically, these 2 rods that it slides back and forth on. If those aren't perfectly parallel and aligned together, then the 2 halves of it can kind of wind up doing this. So even though it does a good job of leveling it at each of these corners, it has no idea what's going on inside the middle of the build plate. So what you can end up with is 2 corners that are either higher or lower than the other 2. So like I say, not a huge deal. You'll still be able to print stuff across the whole build plate. You just won't be able to really dial in that first layer perfectly. And that's really about all that I have to say about the Taz. Like I say, there's a lot of overlap between it and the Mini. It's just bigger. So next up is the Raise3D N2. And I apologize for this awkward angle, but this thing's huge. So first, there's a lot to like about it. It's incredibly sturdy, as much if not more so than the Lulzbots. You have the option to get dual extruders on it, like I've done here, which is pretty fun, and like I say, opens up a lot of options as far as soluble supports and things like that. And as you can see, it's fully enclosed, which means that the heat from the build plate gets trapped in there and keeps it a nice, hot ambient temperature. This makes it possible to print things in some materials that just wouldn't be possible in an open air build plate. That's because some materials like ABS, polycarbonate, and a few others shrink a little bit when they cool down. This can cause lower layers that were just printed kind of curl and bow upward. It can either ruin the bottom corners of your print or cause the layers to separate all over the place. If you saw the project that I did around Halloween of last year, I had initially tried printing it in polycarbonate on the Taz, because it was the only color of orange that I had available at the time. It failed miserably, even though I had a space heater next to it, but then I printed it in ABS on this printer where the heat could be trapped in there, and it came out fantastic. So sure, you can add an enclosure to any other printer, but it's sure nice to have it built in. The next thing that I love on this printer is the touchscreen controls. This is a feature that's becoming more and more popular, but interfaces with as many features as this one I would say aren't very common yet. This is basically an Android tablet, which is connected to and drives the controller board for the actual printer. You can adjust anything on the printer, tweak things as it's printing, manage files, connect to your Wi-Fi, update the firmware, all kinds of stuff. And this setup also gives it a lot of nice connectivity options like Wi-Fi, Ethernet, USB, SD cards. It's really handy. So another thing that they just nailed on this printer that I love about it is the design of the Z-axis. It has 2 huge beefy lead screws in addition to 4 equally sturdy linear rods. You get basically 0 Z-wobble on this thing. And Z-wobble refers to slight inconsistencies that you can get in straight walls if the Z-axis doesn't move up and down perfectly straight and smoothly. Now, as far as the things that I don't like about it, there are a few pretty big drawbacks. The biggest one for me was the build plate. It's huge and it's heated, which is great, but it doesn't have automatic bed leveling. They claim that the bed is leveled and locked into place at the factory, so that you shouldn't ever have to touch it. That was not my experience at all, which I kind of expected, but what I didn't expect was what a huge pain in the neck it was going to be to try and level this thing. A lot of printers with manual leveling have 4 or 5 points on the underside of the bed that you adjust with a thumb screw. It can be tedious, but it's not too bad. On this one, each point has a screw that you adjust and then 2 grub screws next to it that you have to tighten to lock it into place. There's 13 of those points on the bottom of this thing. And to make things even worse, the actual heated layer of it is made of metal. And what happens is it can expand and contract as it heats up and cools down, which just makes it even harder to dial in your leveling. It is such a pain, and I almost sold this because of it. I eventually figured out some mods and some tricks to get around all that, but I can't tell you how much time I spent doing that, and I shouldn't have had to, especially for a printer in this price range. So the moral of the story is either get a printer with auto bed leveling, or do your research and make sure that the one you're getting isn't as much of a pain as this one is to level. The only other big complaint I had with this printer is the extruder that comes with it. It's big, it's heavy, which makes it harder to print things at higher speeds. It tends to grind PLA all over the place, and just all around isn't that great in my experience. I upgraded to a Bondtech extruder on this, which is the same one that the newest version of the Prusa i3 uses, and it's worked much better. I haven't had any more grinding, it's been much more consistent. But again, I shouldn't have had to do that to get consistent results out of a printer in this price range. Alright, 2 left. So the next one is the original Prusa i3 Mark III. And I specify original because Prusa is another company that's really good about open sourcing all of their work, which is pretty awesome because it means that any innovations and improvements that they make, other printer manufacturers can see how they did it and adopt it into their own printers. But it also means that you wind up with a lot of knockoffs, usually made with inferior parts and materials. So the first thing that I love about it, and probably my favorite thing about the whole printer, is the build plate. It's got a nice big heated plate. The surface is made out of steel coated in PEI, so you won't have any problems getting your prints to stick to it. But the cool part is that steel sheet is actually removable. It's being held down by 25 magnets underneath it. So when a print is done, you can just kind of flex it and your parts will pop right off of it. Absolutely love that about that. I wish all printers had that. There are some other printers that have removable build plates, and you can get some removable sheets kind of like this from some different companies. But here it's built in, it's integrated into the design of the printer itself, and it's implemented extremely well. Another cool thing is once the PEI on one side wears out, which it will eventually, you can just flip it over and use the other side. It also has automatic bed leveling using a sensor right next to the nozzle. It uses induction, so kind of like how a stoplight is able to tell that there's a car sitting there waiting to go. But rather than leveling it just at each of the corners like the Lulzbots do, they have it measure 9 points, and I think that they said that in software they interpolate that into a 7x7 grid of points. What that does is instead of creating just a plane out of 4 corners, it creates an actual mesh so that it knows exactly how this bed is shaped. So that combined with the nice smooth PEI sheet that you're printing on makes it so that you can really dial in your first layer and get a nice, smooth, perfect finish on the bottom of your print. I haven't been able to accomplish that on any of my other printers. So yeah, the build plate is far and away the best that I've used and that I've seen on any other printer. The next thing that I love about it is just how intelligent they have made this printer through the sensors that they put in it and just some clever engineering. So just to run through a few of the sensors that it has, there's an optical filament sensor right here just above the extruder, and that's able to detect not only the presence of filament but also the movement of filament. So a lot of other implementations will just detect whether or not there's filament loaded in there. That doesn't help you if your printer jams though, because there will still be filament in there, it just won't be moving. Well, this sensor is able to detect that, pause the print, and ask ask you to fix it, and then it can pick up right where it left off. It's got a new controller board called the Einzi, and that uses some new stepper motor drivers from a company called Trinamic. Those allow it to do some really cool things, but in the context of sensing, they're able to detect if a stepper motor meets resistance, in other words, bumps up against something, or starts skipping. So say that as you're printing, maybe part of the print curls up and the nozzle runs into it. Well, that can cause the motor to skip some steps, and where the nozzle is actually right here now, the printer thinks that it's supposed to be over here. So that can ruin your prints by shifting all those layers above that point over. So the ability to detect that makes it so that the printer can rehome itself and know exactly where the tool head is after that happens. It also makes it so that it's able to detect when it reaches the end of one of its axes without any kind of physical end stop switch. I don't know if there's actually any inherent benefits to that other than just having one less thing that can break and less wires to run throughout the printer. It can detect when any of the fans get stuck, maybe a piece of filament gets stuck in one of the fans, which I've had happen before. They even made it so that it can detect when it loses power, and it can use the energy that's stored in the capacitors in the power supply to get the nozzle out of the way and save where it is in the print so that you can pick right up where you left off if you lose power for whatever reason. By the way, the Raise3D N2 that I talked about earlier is able to do that as well with that Android tablet setup that I mentioned. It has a battery on there that it's able to use for that. It's able to detect the tension of all the belts. It can detect if the frame is just slightly askew. I mean, it's just a really smart, almost self-aware printer, far more so than any of the other printers that I've used. And another thing that I just absolutely love about this printer, and just kind of makes me want to use it more than other ones when I want to just throw something on there to print, it's almost silent. And that's another benefit of using those Trinamic stepper drivers that I mentioned on their new controller board. And if you're more than a few feet away from it, unless it's making really fast movements, you can hardly hear it at all. So here's what the Taz sounds like when it's printing. And then compare that to this. Huge difference. And this is the only printer that I can have running while I'm making a video without worrying about it interfering with the sound too much. Now, as far as things that I don't like about it, there's really not much, and none of them are deal breakers. The first thing is it just doesn't feel as sturdy as the other printers that I have. Now, granted, the other ones that I have are probably more sturdy than average, but I'm definitely more leery of picking this thing up and moving it than I am with something like the Lulzbot Mini. There are also a lot of just kind of wires sticking out and things like that that I'm not a huge fan of. Those things are due mostly, I think, to the fact that this is a kit printer, meaning you buy it as a box of parts with instructions that you put together yourself. You can buy a pre-assembled one, but it's still a kit printer. You're just paying someone else to put it together for you. And honestly, I'm having a hard time thinking of anything else that I don't like about this printer. Yeah, it's good. And last but definitely not least is the Robo R2. And full disclosure, they sent me this printer to check out, asked me to use it in some projects and let you guys know what I thought of it, but they're not paying me for this. They didn't ask me to say anything in particular. These are just my thoughts from using it for the last several weeks. So a few things that I love about this printer. First is just how quick and easy it is to get up and running with it. With most printers, you're gonna have some setup time. Maybe you have to assemble some things, install some software, calibrate some stuff. On this one, from the time that I took it out of the box to when I was actually printing something was literally just a matter of minutes. I turned it on, it had me calibrate the Z offset, which took maybe 30 seconds or so, and I was able to start printing some test models that came loaded on it. Far and away the best box to actually printing something experience that I've had on any other printer. So kudos to Robo for thinking of the user and making that experience as quick and painless as possible. Next, I'm a big fan of just the overall design of this printer, both the aesthetics and the construction of it. It's by far the best looking printer that I have. I mean, compare this to something like the Prusa. Not that I would recommend buying or avoiding a printer based on looks, but given the choice, it's always nice to have a good looking piece of equipment on your workbench. Everything else in the construction is really well thought out as well. It's kind of semi-enclosed with the door on the front. The top is still open, so you might have some troubles printing large ABS pieces on it, but the sides should at least help trap the heat in there, maybe block some drafts, keep cats away from it, so it's nice to have that. It's sturdy too. I would put it up there with the Lulzbot Mini in terms of how sturdy it feels and how comfortable I would be picking it up and taking it with me. In fact, it's got these grips at the bottom so you can pick it up, and it's got a built-in spool holder that folds into the body, so those things make it a lot easier to transport as well. It has a similar design to the Raise3D and some other popular brands like Ultimaker and MakerBot in terms of how the different axes work and move. So the build plate moves up and down for the Z axis, and then the tool head moves side to side and back and forth for the X and Y axes. I've become a pretty big fan of that design. In my experience, it's been a lot easier to get nice, clean, consistent walls out of it in your print with minimal wobble on the Z-axis. The build plate's pretty well thought out as well. It's heated and it's removable to make it easier to get your parts off of it, and it has mesh auto bed leveling like the Prusa. Only on this one it uses an optical sensor to measure the distance between the nozzle and the bed, which is a pretty cool way of doing it. And it's got a couple of other nice features like a filament runout detector, so it can pause your print for you if it detects that you've run out of filament, as well as support for dual extruders with a kit that they'll be releasing soon. The last thing that I want to mention that I absolutely love, and probably my favorite thing about this whole printer, is what's hiding in the base of it. So if you open this panel, then you'll find the controller board for the printer, but you'll also find a Raspberry Pi 3, which is sending commands to the controller board and driving the whole printer. It's running some software called Octoprint. That is freaking awesome to have that set up right out of the box on this printer. And it lets them add some nice features pretty easily, like having a nice touchscreen on the front that lets you control about everything on the printer. I would say even more useful than the one on the Raise3D that I showed earlier, because it'll even let you do things like slice models on a USB drive directly on the printer itself. Slicing refers to the process of taking a 3D model and turning it into commands that the printer can understand. And it's able to do more advanced stuff like this because it's using a Raspberry Pi running Octoprint. It's got USB ports on the front and on the back, it has built-in Wi-Fi as well as Ethernet, it has a web interface that you can log into from any device and control your printer, manage files, start and stop prints. They even have an app for your phone that you can download that lets you do pretty much everything that that web interface does in a much nicer touchscreen friendly format. It even has a camera built in that you can access from that web interface and monitor your prints and even do time lapses on. And they've also got some nice lighting at the top to make that easier. So that's a pretty popular setup, having something like a Raspberry Pi running that software and controlling your printer, but it's awesome to have that out of the box with this with nothing to set up. And as anybody who's familiar with my channel knows, I love Raspberry Pis, and it's just really cool to see it being used in a polished product like this. Now, as much as there is to love on this printer, there are a few things that I'm not a huge fan of. For one thing, it is loud. It's probably the loudest printer that I have. And I wouldn't say that that's a deal breaker necessarily. It probably wouldn't bug you too much unless it was in the same room that you were trying to watch TV or sleep in. But when we have printers coming out like the Prusa and the Lulzbot Mini 2 that are near silent, it's worth mentioning. I've also had some issues with heat creep on this printer. Heat creep refers to when the heat from the nozzle transmits up the filament, making it soften or even expand and causing your printer to jam. That's why hot ends always have this heat sink here with a fan blowing across the fins, and that's to isolate the heat down here at the bottom so that that doesn't happen. It doesn't happen all that often, but when it does, it can be incredibly frustrating. I don't necessarily blame Robo for that problem though. This is the same style of hot end that the Lulzbots used in earlier versions of their tool heads, and I ran into that issue on those printers many times. So I think that this style of hot end is just more susceptible to that problem than other designs. So this is an E3D V6 hot end like you'd find in a Prusa. And here's the hexagon hot end. Notice how much further the heatsink fins stick out on this one and how much thinner they are compared to the ones on the hexagon hot end. It sure seems like this one would be a lot better at dissipating heat than this one. Now, I've been told that they'll be coming out with some custom E3D based hot ends sometime soon, so if you were to stick one of those in here, then that may eliminate that problem altogether. And the last thing that I'm not a big fan of, even though the build plate is designed well and has a lot of nice features, I am not a fan of the actual printing surface itself. It uses something called build tack, and in my experience, prints are much harder to remove from it than something like PEI. And I invariably wind up damaging the print surface at some point trying to remove a print from it, which I've already done on this one. It's replaceable, so it's definitely not a deal breaker. I know that a lot of people love build tack. I'm just not a big fan of it, and I'll be seeing about putting some PEI in here at some point soon. But overall, I have loved using this printer so far, and a big thank you to Braden over at Robo for sending this over, and you guys are going to be seeing me use it a lot more in some upcoming projects. Alright, so now I want to talk just a little bit about print quality, because I know there will be people asking about that. Initially, what I was going to do was take a calibration model and use it on every one of my printers to really fine-tune my settings to get the best possible results out of every one. Then I was going to compare them and talk about which one provided the best results, but what I found was that after taking the time to do that on every one of my printers, the results were so close that it started to feel kind of silly. And I'm not saying that the results were identical with every printer. If you looked really closely, you could see some areas that one printer excelled and other areas where another printer did better. For example, on the Taz, you could see that it had especially good part cooling, so the overhangs came out just a little bit better on that one. And if you forced me to choose, I'd probably say that the Prusa came out just a little bit better in terms of overall print quality than the other printers, but again, the differences were so subtle that you really had to look closely. So I know that's probably not a very satisfying answer, but I guess the takeaway here is that you can get very good results out of just about any decent printer, provided that you're willing to take the time to really dial in and fine-tune your settings for your specific printer, as well as the filament that you're using in a given print. Anyway, I think that about covers it, guys. I hope this was helpful to you guys and that you're better able to go out and look at 3D printers and decide which one is right for you. If not, then I hope it was at least interesting. The next video is going to be about a competition that we'll be hosting over on the forums on sudomod.com. I'll be jumping right into that and getting it out as fast as I can so people can get started on that. I'm really excited for that, so stay tuned for that, and I'll see you guys next time.